Ion beam analysis, (IBA), is another nuclear method gaining ground in criminal investigations. For this kind of analysis, ion beam accelerators are used to speed up ions or electrons, producing a beam of charged particles. When samples of forensic evidence are placed into the ion beam, they emit radiation which can be picked up and analyzed. Using ions enables investigators to understand the composition and origin of the sample, which can help to analyze drugs, explosive and gunshot residues, fake historical artifacts or art. Determining the age and composition of samples means they can be more effectively used as evidence in investigations. Gunshot residues, for example, can help to investigate violent crimes involving firearms. A gunshot residue is a cloud of vapors and particles released from the explosion of a cartridge in a firearm. Nuclear techniques, such as ion beam analysis, help to detect the inorganic components originating from the shot to detect tiny particles on items related to a shooting, e.g., on the suspect's hands or clothes, in order to confirm the identity of the shooter. IBA enables investigators to conduct elemental mapping, which helps in the analysis of specific parts of the evidence and detects tiny traces of incriminating substances, such as microscopic particles of residues on particularly small parts of clothing. Ion beams have also been used to analyze glass shards from hit-and-run accidents, which could prove useful in investigations of crimes involving vehicles. Studies show that through a combination of IBA and machine learning, glass fragments from car windows can be traced back to various car models and manufacturers with up to 80% accuracy. Radiocarbon dating is a method which uses an isotope of carbon, carbon-14, to determine the true age of ancient objects, made of organic materials, and detect forgeries of art pieces. This technique can determine the age of objects up to 50,000 years old and has already helped a number of investigations to determine the authenticity of paintings, statues and other valuable historical objects. For example, in 2019 experts used radiocarbon dating to identify forgeries of two well-known paintings, one Impressionist and one Pointillist. Analysis of the canvas fibers revealed that they were manufactured after the death of the purported artists, which helped to determine that the paintings were fake. Other common nuclear techniques can also be used in investigations. For example, the use of stable isotope analysis for food fraud detection. Stable isotope analysis is a technique used to determine the origin and authenticity of different foods, enabling specialists to detect and prosecute individuals involved in food adulteration, e.g., selling low-quality food under premium labels for high prices. Stable isotopes can be measured with specialized equipment, which can detect the tiniest differences in the ratios of a chemical element's light and heavy forms. Such analysis can provide evidence about a particular type of food in order to make sure it is coming from the right region and uses authentic ingredients described on the label, e.g., detecting sugar syrups added to honey.